Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I bid to every one of you. This is my internet speed for Wi-Fi in my mahalla. It is 26 megabyte per second. Imagine the technology 5G can offers you up to 1 gigabyte per second for the internet speed. It is very, very super fast, I can say, when you can surfing the internet and can communicate online without any lag or buffer as the snap.
Alright, now I move to my slide presentation. So my name is Muhammad Zulhelmie Bin Samsuri, MATRIC number 1720589, and my supervisor is Dr. NORUN FARIHAH binti ABDUL MALEK. And I'm going to present about investigation of beamforming techniques for 5G using Arduino. So this is the table of contents for my presentation, which consists of introduction, literature review, methodology, and lastly conclusion. Firstly, we take a look at introduction, which includes the application, problem statement, and objective. For application of beamforming techniques in 5G, it will focuses a wireless signal towards a specific receiving device. As we can see in the picture, it giving the idea of beamforming where the beams of signal from the antenna will only transmit to particular mobiles, which will give a good transmitting speed data and low interference. Second picture, we can see that with 5G, telemedicine will expand widely, where any doctors from around the world can perform the surgery using webcam without having to be physically in front of the patient. This is due to direct connection that is faster and more reliable, makes it no lag or buffer. Next, the problem statement are frequency bands of 5G will create a high propagation loss because 5G will use high frequency, which around 28 GHz to 300 GHz, and also digital beamforming, which is one of the category of beamforming method, may increase design complexity and power consumption. There are mainly three objectives, which are one, to investigate the existing beamforming technique antenna and beamforming at 5G, two, to design digital beamforming using Arduino, and three, to test and evaluate the effectiveness of digital beamforming. Next, we are going to look at the literature review, which includes summary and previous work. This is the radiation pattern for conventional and beamforming. As we can observe, the biggest difference is conventional antenna will radiate in all directions, while beamforming will only radiate on particular path. As we can see from this table, as mentioned before, conventional antenna will extending the signal in all paths, while beamforming antenna generating directional antenna beam patterns using multiple antennas at the transmitter. For conventional antenna, the antenna have complicated feed arrangements and resonance, which will maximize both the volume and the fabrication difficulties. Meanwhile, in beamforming, it will increase capability by enhancing each user's obtained signal power while limiting interruption signal capacity from other devices. For conventional antenna, a passive omnidirectional antenna that highlighted the whole cell was provided in this base station. In contrast, for beamforming, it uses numerous antenna arrays at the transmitter and receiver to send or detect multiple signals from several desired terminals at the same time to improve device power and efficiency. Okay, now we move to previous works of digital beamforming. There are three previous works. Firstly, they use software Arduino. Algorithm use, they use direction of arrival algorithms, and the summary of the project is they compare voltages to observe the radiation pattern. Secondly, they use software-defined radios or SDRs. Algorithm use least mean squares, LMS, recursive least squares, RLS, and sample matrix inversion SMI algorithms. So the summary of the project is bit error rates were calculated for each case as a function of the interferer power level. And thirdly, they use software MATLAB phase array system toolbox and then transferred to the LabVIEW platform. So algorithm use are minimum variance distortionless response and phase shift beamformers algorithm. So the summary of the project, they take the maximum pointing deviation of the main loop relative to the direction where the target user is positioned, first null bin wheels, and antenna. Now we are moving to methodology. It includes the flowchart and block diagram. So the idea of this research is the transmitter consists of Arduino connected to antenna arrays by RF module will transmit a message according to certain angles, as for example 90 degrees, 180 degrees, to transmit message to the receiver. So if the message transmit accordingly into the direction given, so it is proof that it is beamforming. So the transmitter flowchart, it is firstly power on, then standby mode for Arduino. Then user will input message data. After that, user will input direction in degrees angle. After that, the user have input all the information given, algorithm will calculate it. Then if transmission enable, the message data will transmitted. If the transmission still enable, the message data will transmitted continuously. So for the receiver flowchart, same as the transmitter, the Arduino will power on and it will in standby mode. Then the Arduino will check direction, match with user or not. Then it will check the size of received message. Then after all have been approved, the message will be displayed in the monitor. And if the transmission still enabled, the message still displayed in the monitor. So for the transmitter block diagram, we have Arduino Uno connected to laptop, connected to RF module, connected to antenna arrays. Then for the receiver block diagram, antenna will connect to RF module, will connect to Arduino Uno, and will connect to laptop. So lastly, for the conclusion, using beamforming is one of the way to study about the 5G, and with proper research, we could get the best way to apply the beamforming technique.